Okay, so now we will see by using forward feature selection from machine learning extension that we have imported here. If I will show you here, yeah, this one. Okay, from feature selection, machine learning. From machine learning extension, we have imported sequential feature selector, and here we are going to use forward feature selector. We are using forward feature selector for the purpose that we can check what are the most important features here out of all 21 features, and that can also give almost the same accuracy that 21 features are giving. Okay, so here I have passed the logistic regressor with the best parameter values to that forward feature selector, and here I have make forward is equal to true. Okay, now I have trained my SFS on X train and Y train. Okay, on training data set, and if I will plot this the forward feature selector dot get metric dictionary. It's a method of provided by the same extension. So if I will plot that to see the to visualize the scores as our how forward feature selector work. I have told you explained in the case study of linear regression that it select best feature on the basis of the score. Okay, here I have mentioned that we want uh, ROC area under curve score for evaluation of the feature. So it has selected one feature, then the score was that, and in this way it is selecting the feature in forward you can say flow. It is selecting feature one by one. It is increasing the number of feature and checking the performance, and here you can see our performance is increasing, but here against when the features are 14, after 14 feature when our model has 15 feature, our performance starts to decrease. Okay, so we can say 14 about first 14 features can be most important features. And what are these 14 features? We can see from here SFS dot subsets. If you will see, there are a lot of attributes you can use here. Of this is actually the API for that selection SFS. These are the parameters, and these are the attributes, and below there will be the methods also. Okay, so I am using here attribute subsets. So it will this is giving me the whole detail, like first time it has selected one feature, and when it has just one feature, it has selected the best fit feature, a best feature out of all the features. And you know how it works. It trained the logistic regressor on each feature. Okay, it had divided 21 features and into individual features, and it trained the logistic regressor on each individual feature, then which individual feature will give good score. Okay, or model trained on which individual feature give good score, this will be selected our first best feature. Okay, so in this way here the first best feature is duration, which is giving us the 0.62 approximately area under curve, ROC area under curve score. In this way our score is, as our feature number of features are increasing, our score is increasing. Here you can see, and we will explore from like here from when we have number of features 11, we have score 0.685. When we have 12 features, we have score 0.6857. Again a little bit increased up to fourth decimal place. It has increased a little bit, but in the case of 13 feature, we have 0.6589. Again there is a little bit increase in the accuracy in the performance of the model when we have 13 feature. When we have 14 feature, our score is 0.686, again increase a little bit. And when we have for 15 feature, our model score decrease from 0.686 to 0.685. So we can say we there will be just 14 features. If we will have, it can give us the good score also. Okay, instead of 21 features. What are these 14 features? Most important features, these are the 14 most important features: age, credit amount, duration, sex male, housing on, housing rent. These 14 features we can use, and these are the best features, okay, most important features. And from this you can also analyze which is the first best feature, which is here duration. Second best feature, second most important feature is age. Third most important feature is here purpose radio TV, and it is giving the most important features according to the score, according to the ROC score. Okay, it is giving according to the score. It train the model, and a model will give the score, and on the basis of that score, it is classifying, or it is saying that this feature is most important. Okay, so we have decided that these 14 features are most important here. Okay, these 14 features. So these are the indexes of these 14 features, and here you can see these are the features that are most important here. Now we can train our model on these 14 features, and we will see what our model will give us the score. Okay, I have here created two instances, training data points on these selected features, which has these selected number of columns, and testing data points which has these selected number of columns. These are 14 columns. Now I will train my model 3 on these new training and training data set, and then I will explore what will be the accuracy of that model 3 on test data set. Okay, this will be accuracy. So selected features, when we have selected feature, model is giving uh, accuracy on ROC curve score, area under curve score, on training dataset 0.694, and on test dataset 0.634 in case of selected features, when we have just 14 features instead of 21 features. Previously, when we have all the features, when we were having 21 features, our training score, area under curve score was 0.694 and 0.63. These are almost the same. But here you can see, in that case, we are having 21 features as independent features, and here we have 14 features as independent variables. So we can have here that question that we can use 14 features. Can we use 14 features as our most important features, just as the independent variables instead of 21 independent variables? Okay, so we should explore more to that uh, model on the selected features in that way. Like here, we have not mentioned in our, uh, you can say, problem statement, what will be the optimal threshold, what should be the threshold. So we should want threshold. Here in the problem statement is not mentioned how much recall we want, like 90% or 80% recall want. So we will see in both cases, when we have model on selected features, we will obtain the optimal threshold, and we will see what recall it is giving. Then we will see what was recall given by the model that is trained on all the features. Okay, so here first we have calculated the precision and recalls against the different thresholds when we are having model on trained on the selected features. Then we have calculated the F1 scores, and then optimal threshold according to the maximum F1 score. Okay, now we will check the performance of model 3, which is trained on the selected features on the 14 features, what it is giving here. So it is giving 62% recall and 40% precision, 0.49 F1 score accuracy is also high, 0.6. But in the case of all features, when we have for 21 features, our recall is 82. Okay, so in our case, here we can say we can use recall as our, sorry, we can use 21 features as our independent features, because they are giving more recall on the optimal threshold. Okay, so we can also tweak that model to obtain maximum recall. We can decrease its threshold, like it is using 0.32 threshold, but here we are using about 0.28 threshold here. Okay, We can see from here also if instead of here in the case of model, when we are having model trained on all the features, we have, yeah, we are using 2.85 threshold. If we will use decrease that threshold, we can increase the recall that also. Okay, but here as it is not mentioned by how much recall we want. It is uh, very clear from the problem statement that recall is the best measure, but it is not mentioned how much score of recall is required. Okay, so we will use here the second one model, this one, which is trained on all the 21 features. Okay, so this is our model, and this model we will give to our this model which we have trained. This model we will provide to our bank's team. Bank's team will can use our bank's loan manager can use this model to predict or to classify the customers, either which customer is at risk or which customer is not at risk, which customer will default, which customer will not default. On the behavior of their default or not default, they can approve their loans. Okay, so this model can help the loan managers to take a decision. Okay, so we have done a lot of we have extracted a lot of insights from logistic regression case study. Like first we have done the we have extracted a lot of insights from EDA process. Then we have uh, extracted insight from the coefficient interpretation, that which variable is uh, have strong relation with target variable. Then in terms of accuracy, we have extracted insight from the forward feature selector. For in the forward feature selector, we have seen that duration, when we are using just duration as a feature, one one variable duration, when we have just one independent variable duration, then again there is a 60 plus ROC, area under curve score. Okay, so we have drawn a lot of insights, and based on these insights we can give a lot of recommendations to our bank. Here I have uh, five five recommendations for a bank. You can explore the insights again, and you have a lot of insights. You can give multiple recommendations to your bank. Okay, so you can play with that also. Like here, from our logistic regression model, we have identified that duration is most significant predictor of our customer being a defaulter. Okay, we have seen in the case of forward feature selector that when we have just duration as a independent variable, model was giving good score, as compared to when we have, like in the case of just duration, there was 62% score, and when we have 21 features, we were having about a 68% score, and when we have 14 features, we were having about 66% score, something like that. Okay, so banks should target more male customers as they have less rates of default, and we have seen that male customers have more when we have male customer, there are less chances to default. We have seen from our coefficient interpretation, and here you can also mention about the uh, like the housing out, when the person bank should target the customers who has their own houses. Okay, who has their own houses, because we also have seen that this housing own is also have strong relation with the target variable, with the odds we have seen in the coefficient interpretations. Okay, when we are interpreting our coefficients, so we also saw in our analysis that customers with a little or moderate account in amount in saving or checking accounts are more likely to default. So bank can change their policies. Bank can say, restrict their customers that they should have this amount in their saving or checking account. Okay, so in this way, bank can alter their policies. Customers who are have rented or free housing more likely to default. So bank can should keep, or bank can ask more information from their customers to be able to track them. Okay, so our analysis showed that younger customers are slightly more likely to default. uh, so bank can also alter their policies according to that to deal with that. Okay, so till now we have done EDA part also. We have done model building part. In the model building, we have seen a lot of scenarios, and here we have also we have designed such a model that can help the bank's team, the loan managers, and we also have given some of the recommendation to our banks that they should alter their policies according to that, because data is telling us that way. Okay, so here you have one of the important aspect is that you can draw insights from the EDA, you can draw insights from the logistic regressor also, from the coefficients of logistic regressor. You can also find out the most important features by using your scores. Okay, by using scores, which feature is giving good score by using forward feature selector, and in this way you can carry out your process. You also have figured out which model will be the best for our case, for our bank, according to our problem statement. Okay, as a problem statement has not mentioned about the what accuracy we want. So if you are doing some real term project, you can ask to your team that how much accuracy will be enough if we will what type of model we want here. Okay, yeah, we will try to achieve that accuracy that is required, and sometimes we cannot achieve the required accuracy because of sometimes our independent variables are not having so much strong relation with the target variable. Okay, I hope you got enough. You can work on the insights again. You can play with the different scenarios. You can recommend a lot of other recommendations to your to the bank. Okay, when you will play with, and I will really recommend that you should play with the case study also. Okay, so we will meet hopefully soon. So for now, thank you.